And so for number 7, a curve is such that dy dx is equals to 3x squared plus 10x minus 8. And part A says, find the set of values of x for which y decreases as x increases. So this is just a fancy way of saying find the set of values for which y is decreasing, or for which the curve is decreasing. And we know that the curve is decreasing when the gradient is less than 0, right? So we're going to say this dy dx should be less than 0, right? So first we're going to say 3x squared plus 10x minus 8 equals to 0. So that we get the critical points for this particular curve, right? And for that we're going to use the quadratic formula. So this x will be minus 10 plus or minus root of 10 squared minus 4a then c, right, all over 2a, right? And if you punch this in our calculators, we get x equals 2/3 or minus 4, meaning if we are to draw this as a graph, like our dy dx as a graph, it will look like this, right? Firstly, because the coefficient of x squared there is positive, right? So it faces up like this, and we now know that this is minus 4 and this is 2/3. So it's only in this region where our dy dx is less than 0, right? Where the graph of dy dx is on the other side of the x-axis. So we're going to take that as our range, right? To be minus 4 less than x less than 2/3, right? So it is within this set of values of x where we have our gradient being less than 0, meaning for this range of values of x we have our curve decreasing because the gradient will be less than 0, right? And for the second part, it is saying it is given that the maximum point of the curve is y coordinate 27. Find the equation of the curve, right? So for us to get the equation of the curve, we need a coordinate on the curve, right? And we have a y coordinate of 27, so we need to first determine the x coordinate of that point, right? And we know it's a maximum point, so we are going to find the second derivative, right, which will be after we differentiate 3x squared plus 10x. 3x squared plus 10x minus 8. So for us to find the second derivative, it's going to be 6x plus 10, right? And we're going to substitute 2/3 first, right? Then we're also going to substitute minus 4 to see which one of these points is maximum. And if we sub in 2/3, we get 14, right, which is positive, and that tells us that it's minimum at x equals 2/3. And if we sub in minus 4, that gives us minus 14, right, meaning it's maximum at x equals minus 4. So from here we now know that the coordinate of the maximum point is minus 427, right? So with this we are going to integrate this we're going to integrate this and use this point to find the equation, right? So integrating this, we get 3, so it'll be y equals 3x. We're now adding 1 to the power of x, it'll be 3, then dividing by the new power, plus 10x, add 1 to the power, it'll be x to the power 2 over 2 minus 8x plus c, right? So this will be y is equals to x to the power 3 plus 5x squared minus 8x plus c. And so now for us to find c, we are going to substitute this point, right? And for y, we're going to put 27, then we put our equal sign, then for x, we're going to be putting minus 4, right? So it'll be minus 4 cubed plus 5 minus 4 squared minus 8 minus 4 plus c, right? So we're going to take all this to the left hand side so that we get c, and doing that in our calculators, we get our c to be minus 21, right? So from here we can safely write the equation. It'll be y is equals to x to the power 3 plus 5x squared minus 8x minus 21, right? And that will be the equation for the curve.